These are your steps when you are solving related rate problems. Strongly encourage you to follow these steps. So the first thing you're going to do is identify the quantities and unknowns. We're actually going to label things. If you need to sketch and make a diagram, we're going to be doing a little bit more sketching tomorrow. Don't worry, I will be here to teach that in person. These particular problems don't need a lot of sketches. But we want to find out our quantities, our unknowns. What are we trying to find? Then we need to write an equation that incorporates all of those things. Okay, it might be a volume equation or an area equation or something. Then we're going to differentiate with respect to time. After you've differentiated, substitute into your differentiated equation and solve for what you're trying to solve for. The key is, and where people tend to make mistakes, you have to differentiate before substituting. A lot of people try and substitute in to make the equation simpler and then differentiate. That does not work because you're missing key components to the problem. It's a simplified way to do it. That's a wrong way. So differentiate before you plug anything in. Okay, so a pebble is dropped into a calm pond and this causes ripples, okay, circles. The radius of the outer ripple, so the furthest one out, is increasing at a constant rate of 1 feet per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing? So we need to write down what we're given, what we're trying to find, and then an equation that puts it all together. So let's start with our givens. We've got circles. We know that's a given. The radius of the outer ripple is increasing at a constant rate of 1 feet per second. This is a rate. The radius, so the radius is changing with respect to time at 1 feet per second. So that's one of our givens. When the radius is 4 feet, that's another one of our givens. R equals 4. They want us to find at what rate is the total area changing. So we are supposed to find how the area is changing with respect to time, okay? So the change in area over time, okay? So our givens and our finds. Now we need to write an equation that ties this together. So we have radius and we have area and we know that they're circles. So the equation that we're going to deal with is an area of a circle because we're dealing with circles. We have areas, we have radiuses. So area equals pi r squared, okay? That equation is going to pull everything together for us. Okay, so we've got our givens, what we're supposed to find. We wrote an equation, so now we need to differentiate with respect to time. So we are taking dA over dt. Pi is just a constant, so this is not a product rule. We're going to bring the 2 down. So we have 2 pi r, and we need to still do r with respect to time, so dr dt. All right, now that we have found our derivative, we can plug in. We are trying to find dA dt. We have 2 pi. We were given that we want r to be 4, and we were given that our dr dt is 1. So that's 8 pi. And when we put that into our calculator, we get 25.1. We need to think about our units. This is how the area is changing. So I think our measurements were all in feet here. So our area is square feet per, I don't know what our time was in, second. These were in seconds. All right, in the next video we're going to do a very similar problem with balloon.